Welcome everybody, students and viewers everywhere. We are now in the physics class. This is 20 tutorial, and we want to encourage everybody to pay attention to the very section of physics, because in 20 tutorial we have our physics into four sections. First part, one of the part is physics 001, and that is that one is made up of topics like the topics under the thermal physics as well as mechanics. Then physics 002, then we also have physics 003, we also have physics 004. Now coming back to one of the important topics in physics 001, that is motion. Very important, motion. That's one of the topics under mechanics. The motion can be defined as the state of continuous as a continuous change in the position of the body of an object. It is defined as a continuous change in the position of an object of anything. Now we should understand that motion there are different types of motion. One is circular motion. We have circular motion. Number two, we have the translational motion. Number three, we have rotational motion, or rotary motion, rotational motion. Number four, we have the vibratory motion, or oscillatory motion. Number five, we have a random motion. But let us quickly look at some of them, because today we have to look at the introductory part of this topic, motion. There are other types of motion. First of all, we should know that for the first one, circular motion, we also call it the curvilinear motion. Circular motion, also known as a curvilinear motion. What is circular motion? Circular motion is the motion of a body along a curved or circular path. For example, the motion of the earth going around the sun in its own orbit, that is circular motion. Or the motion of vehicles moving along a roundabout, and so on. That is an example of circular motion. The next one is translational motion. Translational motion is the motion of a body along a straight line. When you see a car moving on a straight line, that is translational motion. Then the next one is rotational motion. Rotational motion is a motion of a body. Let's say there is a motion of a body that turns around about a fixed axis. The motion of a body that moves around its own axis, a fixed axis. An example is the motion of the earth rotating around its own axis, within its own axis. You can say the motion of a CD just turning around. Then again, the next one is oscillatory motion. Oscillatory motion is a continuous, repeated, or can study the to and fro motion of a body about a mean position. An example is the motion of a pendulum bob. Then the motion of a spiral spring, just oscillating like that. The next one is random motion. Random motion is a motion of a body or a collection of particles just moving haphazardly, and there's no direction at all. It's a motion of a body that has no direction. It's kind of zigzag motion, haphazard movement. And for example, is the motion of pollen grains in the air, or the motion of dust here and there. But when we go further, we should understand there are other types of motion we consider, which is a relative motion. And then we should know relative motion is the motion of one body as compared to a second body, which could be moving or which is stationary. That's relative motion. Then we should understand in a study of motion or in a lecture of motion, there are two things we always remember, which is scalar quantity and vector quantity. We should remember that in the study of motion, scalar quantities are very important, as well as the vector quantities. Scalar quantities are physical quantities that require just only the magnitude. no direction is needed to specify it or to describe it. The other one is the vector quantity. Vector quantity is a physical quantity that require both magnitude as well as direction to completely specify it or to describe it. Very, very important. We should not forget that as we go further in the study of motion, we see a lot to consider. And one of the things we always consider in the study of motion is the concept of motion. The concept of motion, which we will consider in our next class. The concept of motion to consider are distance and displacement, speed and velocity, acceleration and deceleration. Then we will go further to consider the equations of motion. Then when we come next time, we will look at the difference between distance and displacement, and which one is a scalar and which one is vector. We will also consider the difference between speed and velocity, which one is scalar and the one that is vector. Then we'll go further to consider acceleration and deceleration too. Then we'll continue to derive the equation of motion, the various equations of motion. Then we still consider the motion that has to do with vertical fall, or has to do with vertical direction, or vertical motion will be considered, as well as the equation that concerns them. Then all kinds of problems that has to do with the equation of motion. Then when we are through with that, we will consider the aspect that has to do with the equation, the motion graphs. The motion graphs are displacement time graph as well as velocity time graph. Then all kinds of equations that we should expect under the calculations in motion equations. Then finally, we should also understand that in the study of the motion graph, there are calculations that we still have to consider there too. So we will be getting ourselves ready in the next class to go deeply and in details in the aspect of the terms as to do with the terms in the study of motion, as well as the calculations under equations of motion. So let's prepare ourselves. We'll see you in the next class. Thank you very much. Good afternoon, everybody. You're all welcome to the Turning Points tutorial. Once again, I just want to remind you that, like I said before, we'll continue from the place we stopped before. We talked about motion and the concept of motion. We only had the introduction last time, but now we want to go into details. We want to consider the concept of uniformly accelerated motion. Remember, don't forget that last time we said something about motion, that motion is a continuous change in the position of a body. That means that as the body changes its position from one point to another, there will be a change in either distance or displacement. And the change in displacement or distance will eventually lead to what is called speed. And listen to this carefully. We will talk about some parameters we use in discussing motion, uniformly accelerated motion. And those parameters or those concepts are distance and displacement. We'll see the difference between two of them. We'll also go further to talk about speed and velocity. Then we'll discuss acceleration and deceleration. And along the line, we'll talk about the relationships between the acceleration, uniform velocity, and some other quantities too. We'll talk about uniform initial velocity and final velocity, time, as well as displacement or distance, how they are related. That will now lead us to the equations of motion. Before we go into such, let's come back to discuss the concepts one by one. Like I said before, all the concepts are as follows. Let's look at it on the board now. We will talk about distance and displacement. Distance and displacement as one of the concepts of motion. Then not only that, we discuss in detail speed and velocity. Speed and velocity in details. Then we'll talk about the other ones like that of acceleration and deceleration. Then finally we will go to the aspects of the equations of motion. Then when we are through the equation of motion in the next class, we will talk about calculations under the equations of motion, whether it's going to be the one that has to do with that of free fall or horizontal movement. Let's come back to the very first one now. We discuss that of displacement and distance and displacement as the first concept to consider. Distance and displacement. Now, the question is, what is distance and what is displacement? Looks as if both of them are alike, but we cannot just end up and say that they are alike in terms of definition, but we will see the difference because we will consider it based on whether one is vector quantity or scalar quantity. And you don't forget, we said before that vector quantities are quantities that have both direction and magnitude, but for the scalar quantity, just only magnitude. There's no direction to specify it. But let's now go back to the aspect of the definition, distance. What is distance? Distance is a measure of the space separating two positions without consideration of the direction between the two positions or the 2 points. Once again, I said distance is defined as a measure of the space separating two positions without consideration of the direction between the two positions. That means you will not look at the direction, you will not consider the direction, only the measure of the space separating the two positions or the 2 points. But on the other hand, displacement. What is displacement? Displacement, on the other hand, is a measure of the space separating two positions along a given direction. That means in a specified direction. You must talk about the direction. When you come to displacement, you must talk about the direction, not only the measure of the space separating 2 points. You must talk about the direction that is involved. That's why we can now say that the difference between distance and displacement is that distance is actually a scalar quantity. There is no direction to specify it. But that of displacement is actually really a vector quantity because it has both direction as well as magnitude. There is direction to specify the magnitude. Okay, we want to actually say very, very important here that the SI unit for measuring distance and displacement is meter. Other units that we can also use that are connected to meter. Other smaller units are centimeter, millimeter, but the SI unit is meter. Let's go further to say here that there are other things we need to look at when we consider distance and displacement. If there's a change in distance, if there's a change in displacement, then something will occur, either speed and velocity. Now we'll come to the other aspects. The other aspect of the concept of the uniformly accelerated motion is that of speed and velocity. Now we are through with distance and displacement. Now we look at speed and velocity. Speed and velocity. Speed and velocity. Now here, once again, we can also say just like in the case of distance and displacement, speed and velocity almost look alike. It looks as if both of them have the same definition and the same, let's say the same unit, but there are differences. You can see the clear difference between speed and velocity. Even if they have the same formula, the same unit, but the difference is that one is scalar quantity and one is a vector quantity. There are still other differences, but let's consider the definition for speed. The definition of speed and that of velocity. You should know quite well that speed is defined as the time rate of change of distance. Defined as the time rate of change of distance. Is the rate of change of distance with time. Now, it's the time rate of change of distance, or we can say it is the rate of change of distance with time. But on the other hand, what is velocity? Now, in the case of speed, we use distance, but in the case of velocity, we make use of displacement. You see that now? You see, in the case of distance, what is actually, in the case of speed, distance is connected to speed, and because distance is scalar quantity, that's why speed is scalar quantity. But in the case of velocity, displacement is connected to velocity in the definition. What is now velocity? Velocity is defined as the time rate of what? Time rate of change of displacement. Is the rate of change of displacement with time. Is the rate of change of displacement with time. Velocity is actually the time rate of change of displacement, or the rate of change of displacement with time. Now, if you look at it very well, since displacement, I said again, is scalar vector quantity, therefore velocity is a vector quantity. Since distance is a scalar quantity, therefore speed is a scalar quantity. Now let's repeat the definition of speed once again. I said speed is defined as the time rate of change of distance, or you can say the rate of change of distance with time, as the rate of change of distance with time. And it means that mathematically we put this very way. Mathematically, what is speed? Speed v is equal to distance covered all over time taken. Distance covered over time taken. Now remember, we use small letter v to represent or to denote speed. We also use small letter v to represent velocity. So we can write here that v speed, v is equal to, now distance. What do we use to represent distance, to denote distance? We can use small letter x to denote distance. We can use small letter s to denote distance. We can use small letter d to represent distance, and any that maybe small letter y, whatever it is, to represent distance. Now for the purpose of our own personal consumption, library class, or personal interest, we want to make use of small letter s for distance and as well as for displacement. Let's not just get it like a kind of a confusion within your mind. Just make use of s as the symbol for distance in this our class here. Now distance s all over time, and its time is represented by a small letter t. So we can write here that speed is distance cover s all over time taken t. Let's assume this is equation 1a. Well, I know why I'm saying 1a. Now, in the case of the units for measuring distance, speed. The unit for measuring speed is based on what we have here in this relation. Now, what is speed? Speed is distance covered over time taken. Now, look at it from that of our. When you come to derive quantities, you understand here that we can derive the units from this formula here, and the formula we have, the unit for distance is meter, and the unit for time is seconds. Let's say seconds, s for second. And if you rewrite it, it means that you will have it like meter. You have it here as meter / second, or in the form of indices meter per second, like this, either like this or like this. So the SI unit for speed is meter per second, meter / second, or meter per second, this way, ms raised to power -1. Now, just have it in mind, the unit for speed is meter per second, and that same unit for speed is also used as a unit for velocity, because both of them have the same formula. Then let's come back again to that of this velocity. What is velocity? Velocity is defined as the rate of change of displacement with time. You can say it's the time rate of change of displacement. It is the time rate of change of displacement. Velocity is defined as the rate of change of displacement with time. Velocity, the rate of change of displacement with time. Then what we say about that? For velocity, we want to write it mathematically. we use V to denote velocity, and mathematically it means displacement covered all over time taken. Displacement covered over time taken. Just this, it's not as exactly what we have in the case of speed. And then we can write here that displacement, we use small letter s to also represent displacement. That means displacement s all over time taken t. So we can say here that the velocity is equal to displacement s over t, that's displacement covered all over time taken. And we also know that since displacement is measured in meters and time in seconds, we can also say here that we write it this very way, m over s, meter over second, which means meter slash second, or meter per second. That's what we need to know here, that the SI unit for velocity is also the SI unit for speed, meter per second. The only difference is that speed is scalar and velocity is vector quantity. Let's come back to the next aspect of the concept of uniform acceleration. We've talked about the first one, which is distance versus displacement. We have talked about this speed versus velocity. But we cannot just go to the next concept if we don't go further to look at other aspects of velocity. Now, for another aspect of velocity, we want to consider some cases like uniform velocity and non-uniform velocity. We also talk about the aspect of average velocity. Now we consider these three aspects of velocity, then we will go further. Then the first one we will consider now in the aspect of velocity is the average velocity. Then we'll go into the uniform velocity and the non-uniform velocity. But in the aspect of the average velocity, what is average velocity? Average velocity is defined as the ratio of the total displacement covered to the total time taken to cover the displacement. I said it is the ratio of the total displacement covered to the total time taken to cover the displacement. So we can write here that this way mathematically, for that of the average velocity mathematically it is given as follows. Total displacement all over total time all over total time, and just have it here in mind that the V bar you are seeing here, the V bar is representing average velocity, or V subscript A. We can use V subscript A to represent average velocity, or V bar to represent average velocity. Whichever one you want to take, you can choose one. Then you can say, okay, let's just make use of V bar always to represent average velocity. Now, mathematically, we can write here that V bar is equal to what's displacement? Total displacement, that is S, all over total time taken T. Then call this one equation. Let's call this one equation 1A, equation 1B. Then you can also call this one equation 1C. Alright, let's move ahead to the next aspect. We have talked about the aspect of average velocity. Then we want to go to the aspect of uniform velocity. Uniform velocity. Uniform velocity. What is uniform velocity? Uniform velocity is a motion situation in which a body covers equal displacement in equal time interval. It's a motion situation in which a body covers equal displacement in equal time intervals, no matter how small the time interval may be. I will take it again once again. Uniform velocity is a motion situation in which a body covers equal velocity in equal time interval, and no matter how the time interval may be. Now you should let's see some examples. Like for example, you talk about like when you see something like 5 meters per second or 4 meters per second. Then let's say 6 meters per, let's say 2 seconds, something like that. This tells us that for every one, say per second means 1 second, per second means 1 second. When you say per 2 seconds means for every 2 seconds. Now in the case of 5 meters per second, that means for every 1 second, 5 meters. For every 1 second that passes by, you must have covered 5 meters. For that 1 second, 5 meters have been covered. If a car is traveling on the road on the way, and then if the car moves to a particular point, you check as the car is moving on its way, then you check the time. For every 1 second that passes by, 5 meters has been covered. Or you can say 4 meters per second means that for every 1 second that passes by, you must have covered 4 meters in your movement. Or you can say 6, if you talk about in case of 6 meters per second, this means that, sorry, per 2 seconds, this means that for every 2 seconds that passes by, then you must have covered 6 meters. These are examples of uniform velocity. Then the next aspect is the non-uniform velocity. Non-uniform velocity. A non-uniform velocity. Now, what is non-uniform velocity? Non-uniform velocity is a motion situation in which a body covers on equal displacements at equal time interval, no matter how small the time interval may be. Or you can put it this way: it's a motion situation in which the velocity of a body changes within a given interval of time, making the body to cover unequal displacements in equal time interval. Once again, what is non-uniform velocity? Non-uniform velocity is a motion situation in which the velocity of a body changes within a given interval of time, making the body to cover unequal displacement in equal time interval. Now, see an example is that of when you see a body moving with, for example, if a body is moving, or if a body was moving with a velocity of, let's say, 4 meters per second, and later on changes to 8 meters per second, or if a body was moving with 5 meters per second, later on changes to, let's say, 3 meters per second, it doesn't maintain that distance covered for every second. At the first time, if a body was moving with 5 meters, moving at the rate of 5 meters per second, and it means that something maybe happens on the way, and the car slows down. And what happens? What the person will do is to reduce the length of the distance covered from 5 to 3. But for every 1 second that passes by, it's no more 5 meters per second. It's now 3 meters for 1 second, because the car slows down. There's a change in speed. Either there is an increase in speed, either from 4 to 8, for instance, or a reduction in speed, either from 5 to 3. Now, the next aspect to consider is let me just go back to something very, very important, lest I forget. I just want to recall back to what we said about the average velocity. We said average velocity is v bar, which is equal to s over t. Total displacement covered over total time taken. But let's not forget, average velocity can also be written in another way. Average velocity is also the average of the initial and the final velocity. Initial velocity and final velocity. From what we said about non-uniform velocity, there will be a change in velocity. Initial velocity, since there's a change in velocity, the first velocity that the body moves with will be called the initial velocity, and we use small letter u to represent initial velocity. Why small letter v will be used to represent final velocity? Then there will be a change, because there's a change in speed and velocity. Then the change in speed or the change in velocity will now be given as delta v. Delta means change in velocity, which is equal to the final velocity minus the initial velocity. So anywhere you see delta V, it means final velocity minus initial velocity. V for final and U for initial velocity. Now, like I said before, average velocity can be restated in that way. It is the average of the initial and the final velocity. So we can also rewrite it this very way, that average velocity V bar is equal to the average of the final and the initial, I mean V plus U divided by 2. That is another way we can write our average velocity. Let's call this one equation 2. Average velocity V bar is equal to V plus U divided by 2. Then the next aspect is our definition on acceleration and deceleration. Another concept to look into. Acceleration and deceleration. Acceleration and deceleration. And in this aspect, we will also go further to talk about uniform acceleration and non-uniform acceleration. But let's just look at the aspect of acceleration and deceleration before then. Now, what is acceleration? What is acceleration and what is deceleration? First of all, let's talk about acceleration. Acceleration is defined as the time rate of change, or the time rate of increase in velocity. Is the time rate of increase in velocity. We can also say it is the rate of increase in velocity with time. It is the rate of increase in velocity with time. Then sometimes some person will say it's the rate of change in velocity with time. Whichever way you can say is the rate of increase in velocity with time, because we also have the other side of acceleration, which is the opposite of acceleration, and deceleration, which is the rate of decrease in velocity with time. Now, we can also say here in the aspect of deceleration, remember deceleration is also called retardation. And retardation or deceleration is the rate of decrease in velocity with time. The rate of decrease in velocity with time. Now, let's go back to that of acceleration. We said that acceleration is the rate of increase in velocity with time, or it is the rate of change in velocity with time. Now, mathematically, we want to take it down. Remember, acceleration is represented by small letter a. So we can say it implies that acceleration here is equal to change in velocity. Change in velocity is a positive change, not a negative change. So we can see increase in velocity, but change in velocity all over time taken. And we can rewrite it as acceleration A is equal to delta V. Delta means change, and all over t time t. And that delta V, remember we said delta V means V minus U, which means V minus U all over t. This is equation, or we can now write it, therefore we can say A is equal to V minus U over t. Equation, let's call this one equation 3. Then remember, in the case of deceleration, deceleration is a negative of acceleration. When you write V minus U all over t, and if the answer you have carries a negative sign, therefore what you are dealing with is deceleration. Acceleration and deceleration have the same units. They have the same units. And what's the unit for acceleration? The unit for acceleration is meter per second square, and the unit for deceleration is meter per second square. Now look at it. Why is it so? Because when you say acceleration, velocity over time, rate of change of velocity over time taken, and you know velocity is meter per second, and time is also in seconds. When you work it out, apply the indices here. You have meter per second per second. That means you are saying meter per second, that's s raised to power minus 1, s raised to power minus 1, second raised to power minus 1, and seconds raised to power minus 1. Work it out using the indices. You have ms raised to power minus 2. That is meter per second squared. Now, that is all for that. We want to move on to a definition once again. Acceleration is the rate of change of velocity with time, while deceleration is the rate of acceleration is the rate of increase in velocity with time, while deceleration is the rate of decrease in velocity with time. known as a negative decrease. Now, a negative change. Then the other aspect to look into is the uniform acceleration. What is uniform acceleration or deceleration? For uniform acceleration or uniform deceleration, anyone. Uniform acceleration is a motion situation in which equal increase in velocity takes place in equal time interval, in which equal increase in velocity takes place in equal time interval, no matter how small the time interval may be. Equal increase in velocity takes place in equal time interval, no matter how small the time interval may be. Uniform deceleration is a motion situation in which a body experiences equal decrease in decrease in velocity in equal time interval, no matter how small the time interval may be. Once again, uniform deceleration is defined as a motion situation in which a body experiences equal decrease in velocity in equal time intervals, no matter how small the time interval may be. Now we want to consider non-uniform acceleration. Non-uniform acceleration is a motion situation in which a body, or you can say is a motion situation in which the rate of change in velocity is not constant in all time within which the body is in motion. Now, we can also look at other aspects concerning the expressions given to us. The expressions we have here concerning acceleration. Acceleration is v minus u over t. Now we are through with all this. Since we have looked at the concept of distance and displacement, the concept of let's say we are talking about the concept of distance and displacement, we are talking about the concept of the speed and velocity, and that of the acceleration and deceleration in all aspects. We will go further in our next class to talk about the equation of motion, how v, u, a, and t and s can show some relationship. We want to talk about the three equations of motion, how to derive them. Thank you very much. We'll see you later.